Okay, for example 4, again, we have two triangles. We have triangle ABC and we have triangle DEF. And we're going to try and see if they are in fact similar to each other. So what I want to do is first identify a scale factor using what appear to be corresponding sides. I have side length AC, which is the long side on this triangle, which is 18 units, and on the long side on this triangle, side DF is 6 units. Okay, and I can go either way. Just remembering that R, our scale factor, is new over original. Now, because we don't really have a new or an original identified, you can pick and choose. And just personal preference for me, I prefer to have the larger number be on top. So I'm going to put my 18 over my 6. And I'm going to say that that's going to be 18 divided by 6 is 3. So our scale factor here is going to be 3. Okay. All right, so we're going to come up with a sequence that will map the smaller onto the larger. And we're going to use a scale factor of 3. So that's going to be our first part of the sequence. So we're going to dilate triangle DEF, and this one's tricky because the sides the vertices are named differently, but that doesn't mean they can't be similar. Okay, you're proving it through your sequence. So we're dilating DEF from center to O. By our scale factor of 3. Okay, so we need to identify these points. Okay, so I just noticed that we have points that are in the middle of grid lines. So I'm actually going to change what we're doing, and we're going to work from ABC to DEF because these points happen on the intersection of grid points. It's a lot easier to identify their names. So because we're going to go from bigger to smaller, we're going to use the reciprocal of our scale factor, 1/3. Okay, back to business. So A, we're identifying coordinates, is at -9, 3. B is at -3, 6, and C is at -2, 9. And we're going to multiply each of these by 1/3, or the same thing would be to divide by 3. Well, -9 divided by 3 is -3, and 3 divided by 3 is 1. So we're going to be at -3, 1. We'll make that A prime. -3 divided by 3 is -1, and 6 divided by 3 is 2. We'll make that B prime. And -2 divided by 3 is -2/3, and 9 divided by 3 is 3. So we're going to be at -2/3. I need to kind of eyeball that, find where 2/3 would be. So it's going to be about right there. There's my C prime. Okay, so I've dilated by 1/3. Now what I need to do is translate. I need to identify corresponding points. So I'm kind of looking at my side lengths. I have my long side, short side, short side. So it looks like maybe C and F are corresponding points. So I'm going to translate until those are touching. So translate triangle, A prime, B prime, C prime. And we're going to translate it 1, 2, 3, 4, 5 units to the right. And, I forgot. We're at -2/3. Let me see. Let's just create a vector. We're going to create a vector. And the reason being is because we can't count exact grid lines. So I'm going to create a vector from C to F. So instead of doing units, we're going to translate along vector CF. Okay. And then once we get there, we have a shape that's about like this. And we need to rotate. I'm going to take this long side and rotate it all the way around until it lies on that line DF. So we're going to rotate clockwise. Around, and because it's not on an exact grid point, I'm just going to name it point F. Okay, and so then I'm going to end up with a shape that's right there. Now I can reflect it over line DF. Okay, and then I end up having mapped my triangles onto each other. So therefore, triangle ABC is similar to triangle DEF.